The C programming language was written by and for assembly language programmers. Other languages are made to program in specific styles, objects, data structures, dynamic types, abstract representations, and other things, but C was designed to program computers. It's so much like the underlying hardware that it was necessary to invent operators that were unheard of in upper-level languages until C introduced them. Unix was originally written in assembly language. The assembler is simply named A. It was found by assembly programmers that certain things were done over and over, and to speed things up a bit, the language B was designed to automate some repetitive tasks. It worked so well, the process was taken further, and an improved version of the language was derived, and the language C was born. And it worked out so well, Unix was completely rewritten, and almost all of the assembly language was replaced. That made Unix portable. By porting the compiler and its library to a new system, you could port Unix by compiling it. Whenever a new computer was designed, the easiest way to get an operating system for it was to compile Unix. So Unix and Unix-like systems spread. It was discovered that C was an excellent language not only for operating systems, but for anything. So C spread out from Unix and went everywhere else. The 1980s was the decade of expansion of C. Many compilers were written. There was no standard other than the K&R, the book on the C language written by Kernighan and Ritchie. The first standard for C came out in 1989, and it was called the C89. It was quickly followed by an update a year later. It's known as C90. The two are basically the same language. C90 includes a few minor corrections and oversights. The latest version is C99. Which is the version of the standard 10 years later. And it is the version that we use today, and the version that this course is about. C has had an influence on almost every programming language devised since C was around. This is a partial list of those directly derived from the syntax of C. There are others, but these are the most popular. You've heard the term context-free grammar when referring to the syntax of a language. That means you can determine the meaning of a keyword or a symbol without looking at the context in which it is used. For example, the word else or the equal sign always mean the same things no matter where they appear. C is almost context-free. The only exceptions are the characters less than, greater than, and colon. What they mean depends on where they are used. Less than and greater than can be used for numeric comparisons, or they can be used to quote file names for the preprocessor. A colon can be used to define a bit field, or it can be used in a special shorthand form of if-else. I'll be showing you how all these things work later in the course, but other than these three exceptions, the syntax of C is context-free.